is on forces, and force is simply a push or pull on an object. So here we're going to be talking about Newton's three laws of motion. Newton's three laws of motion is named after Sir Isaac Newton. He is considered the godfather of physics. All right, so the first part of physics is more dynamics, all right, which means what causes motion is the study of what is the cause of motion. All right, and then the Newton's three laws of motion are at the heart of this dynamics for physics. All right, so dynamics is the study of the motion and the forces that cause the motion. So what will be the four forces of nature is gravitational, electromagnetic, strong, and weak nuclear forces. We won't get too far into nuclear right now because that's going to be later on in, I think, forgot what chapter, but we're not going to get too hung up on nuclear forces for right now. And then the electromagnetic spectrum is something that we will talk about later in the semester. So for right now, gravity, weight, normal force, tension, and friction, those are the common forces that we're going to focus on for right now. All right, so gravity is caused by anything that has mass. So if you have mass, whatever the object is, and it's on the Earth's surface, the gravity of Earth is 9.8 meters per second squared. All right, so this is gravity is pretty much gonna be that 9.8 meters per second square on Earth's surface. So for the moon, it's gonna be different. For another planet like Jupiter, Mars, it'll be different as well. All right, but gravity is a force. We're not gonna focus on electromagnetism or nuclear forces right now because we'll talk about those deeper in a later chapter. All right, so again, Newton's laws of motion are named after Sir Isaac Newton, and he is considered the father of physics. All right, so getting into the laws of motion. Now, this is the stuff you do need to know. Okay, so there's three laws of motion. This is the first law. The first law states that an object at rest will remain at rest, or an object that is in motion will remain in motion unless it's acted on by an outside force. All right, so inertia is directly proportional to the object's mass. All right, so an object, whether it's moving or not moving, will remain in that initial state unless there's an outside force acting on it. So external force just means outside force. And don't forget, force means a simple push or pull on an object. All right, so the second law of motion, this is where you have acceleration on a mass by a non-zero net force. So there's some sort of force to the object in order for it to accelerate. So your acceleration is inversely proportional to the mass. Now here, this is the equation that you need to put on your formula sheet. We will be working with this equation from here on out. Even in physics 2, if you have to take it due to your major, you're going to have to know this as well. So for the second law of motion, force is equal to the mass of the object times the acceleration of the object. All right. Force is equal to mass times acceleration. Make sure you update your formula sheet each and every time we go over a new chapter. All right, and then the third law of motion. For every action, there is an equal and opposite reaction. Okay, so if let's say there's a swing door and you're coming into one of the buildings on campus, all right, you push on that swing door. Once you go through the swing door, that swing door is going to go back to its initial state. All right, it's going to close right back up. All right, so for every action, there is an equal and opposite reaction. All right, so forces are vectors. So last chapter, we did discuss vectors, and vectors have both a magnitude and a direction. So magnitude simply means the numerical value, and the direction means, your compass direction in which the force is being pushed or pulled. All right, so again, a force is simply a push or pull on an object. All right, so sometimes that means there's going to be contact between those objects, but sometimes there's also non-contact, like gravity. All right, gravity is a force. All right, so don't forget, force is a vector, so it has magnitude and direction. All right, so don't forget how to draw a vector. All right, you start from your starting point, and then you end it with the arrow pointing in the direction of motion. All right, so this is a free body diagram discussing this different types of forces. So you have a push, you have a pull, you have a shove, you have a tug. Just different words that describe force. All right, so the units of force. Again, we said force was mass times acceleration. The SI unit for mass is kilograms, and the SI unit for acceleration is meters per second squared. All right, which means kilograms times the meters per second squared is equal to a Newton. All right, so this SI unit for force is named after Sir Isaac Newton. The symbol for Newton is capital N. All right, so we have discussed weight already. That was a part of our first lab report where we weighed two small objects. Some of you guys did pencils and pens or calculators or iPhones, where you did weight is equal to mass times, and instead of acceleration, we used gravity, since gravity is a form of acceleration in the downward direction towards the Earth's surface. So your gravity for Earth was the 9.8 meters per second squared. So some of this stuff should be reviewed for you guys. So force is equal to mass times acceleration, or mass times gravity. All right, so weight is equal to mass times gravity. So weight in itself is a form of force. All right, so weight is always directed downward towards the Earth's surface. And I did already put these slides on Moodle as well. All right, so we also have talked about weight versus mass. So your mass is the amount of matter inside of an object. And then your weight is the mass times the effect of gravity. So whatever your mass is, you multiply that times 9.8 meters per second squared. Right, so know the difference between mass and weight. Mass is the amount of matter in an object. Weight is mass times the effect of gravity. All right, so your weight, which is mass times gravity, is pointed downward. There is also a normal force that acts back on you anytime that you're standing on a surface. All right, we don't think about it like that, but it's true. So if we're standing, on a wood floor, that wood floor is supporting our weight. All right, so it's applying a force back on to us. If it didn't apply a weight, then we would sink right through the floor. So the floor is sustaining your weight, your mass times your gravity, and this is called the normal force. Right, so if we set a box on the ground is applying a force to the box, or else the box would just keep on going downward and downward and downward. Right, so the normal force is always perpendicular to the surface, no matter what the surface is. All right, so tension force Anytime you have a object attached to a rope or a string or a cable or a wire or a chain, there's tension in that string or cable. All right, so tension is directed upward along the rope or the cable. All right, the weight of the object is always pointed in the downward direction towards the Earth's surface. So the tension is directed upward into the wire. Right. All right, so friction is a force that opposes the motion. So if you think about, how you drive a car and you apply the brakes are a form of friction, right? It's acting in the opposite motion of which the car is moving. So instead of the car moving forward, it's beginning to slow down to come to a complete stop, right? So think of brakes on a car as a form of friction because it opposes the motion of the car. So there's different types of friction. You have static. Static means it's not moving. You have kinetic friction. Kinetic means motion, in motion. Air resistance, rolling friction, and water resistance. So there's different types of friction. All right, so static friction, this is the force that opposes an object before it's even moved. All right, so your static friction is down here, and it's just a force, subscript S. And you have your kinetic friction. So this is the force that opposes the object's motion while it's in motion, so while it's moving. All right, so kinetic friction, that's going to be F subscript K. All right, these are some coefficients of friction, nothing that you need to memorize. Anytime you need a coefficient, I will give that to you on a quiz or a test. But if you actually need it, it's not something that you need to take up space on your formula sheet with. All right, terminal velocity. So this is when you have air resistance and it's equal to the weight of a parachute and the jumper. So the acceleration stops and he reaches terminal velocity or constant speed. So it's a point where you're no longer speeding up or slowing down. Your speed is just constant over time. So don't forget, acceleration is a change in velocity or speed over time. All right, so in summary, all forces are vectors, so they have both magnitude and direction. All right, so there's four basic forces. We got gravity force, electromagnetic force, and then strong and weak nuclear forces, which these three we'll talk about later. So don't worry about those for right now. And then we have our Newton's three laws of motion. So Newton's first law states that an object at rest will remain at rest, or an object in motion will remain in motion until acted on by an outside force. Newton's second law is force is equal to mass times acceleration. Newton's third law, for every action, there is an equal and opposite reaction. All right, we also talked about the difference between mass and weight. Mass is the amount of matter within an object, and then weight is the mass of an object times the effect of gravity on that object. All right, so our normal force, this is always going to be perpendicular to the source, to the surface, no matter what the surface is. So perpendicular just means a 90-degree angle. And then we talked about friction, which is a force that opposes motion. So anytime you think about an example for friction, just kind of think about the brakes on a car and how, applying brakes as you're moving forward will begin to slow you down so that you can come to a stopping point. All right, so let's work out a couple problems. Okay, number one, using Newton's second law equation, which is force is equal to mass times acceleration, If we have a mass of 55 kilograms and a force of 40 newtons, what is the acceleration? So let's go ahead and let's work this out. All right, so this is number 1. All right, so our equation of Newton's second law equation is force is equal to mass times acceleration. All right, they gave us the mass and they gave us the force, and we're asked to find acceleration. So acceleration is the unknown variable. All right, so we're looking for acceleration. So let's put a question mark by A. And they gave us the mass, that was 55 kilograms, right? Since mass is already in kilograms, we don't have to do any conversions because that is the SI unit for mass, kilograms. And then they gave us the force. All right, force was equal to 40 newtons. 40 newtons. To get our acceleration by itself, we need to divide both sides by the mass. So the mass will cancel on the right-hand side, and we'll end up with acceleration being equal to force divided by mass, because the masses will cancel on the right-hand side. All right, so let's plug in what we have. For force, it's 40 newtons, so that's in the numerator. And then our mass is 55 kilograms, so that's in the denominator. You should have gotten point, yep. So you could do 0.727, or you can round to 0.73. So 0.7 meters per second squared. Right, so don't forget Newton is mass times acceleration. Meters over second squared. Right, so the kilograms in the numerator and the kilograms in the denominator will cancel out. So you're left with meters over second squared. All right, acceleration is the change in velocity over time. Velocity is meters per second, so acceleration is meters per second squared. All right, let's read number 2. All right, using Newton's second law equation, which is force is equal to mass times acceleration. If we have a mass of 120 kilograms and an acceleration of 30 meters per second squared, what is the force? All right, so let's work this out. All right, so this is number 2. Force is equal to mass times acceleration. And we're asked to find the force, so that's the unknown variable. All right, the mass is 120 kilograms, and the acceleration is 30 meters per second squared. So mass is 120 kilograms. And since it's already in kilograms, we do not have to convert, because kilograms is the SI unit for mass. And then our acceleration is, I think it's 30. Yeah, 30 meters per second squared. Right, so all we have to do is plug in. Since force is already on one side of the equation by itself, all we're doing is multiplying 120 kilograms times 30 meters per second squared. All right, so 120 times 30, 3,600. All right, so we have kilograms times meters per second squared. You're multiplying these SI units times each other. Kilogram times meters per second squared is also known as a Newton. So you could put capital N, or you could put kg times m over second squared. For your answer, I would take either of these SI units, but you need to make sure you include the SI units with your numerical value, or you're going to lose point.